The CM-5 is a scalable parallel supercomputer whose performance can grow transparently from gigaflops machines with a few dozen processors to teraflops machines with thousands of processors. It is designed to run efficiently the most demanding of computational algorithms, including irregular and dynamic grid topologies. The key to these capabilities lies in its unique network architecture. This simulation of the global climate uses an irregular and dynamic mesh to focus effectively on changing weather patterns. In this application, the connectivity of the mesh actually changes from one step to the next. On the CM-5, mesh data is distributed among the processing nodes. Exchange of data between mesh cells is done through the CM-5 data network. Here, the messages are indicated by pulses of light. The network scales with the number of processors. 4 16-node network trees are connected to build a 64-node network. 4 64-node network trees are connected to build a 256-node network. Each time a level is added to the tree, the bandwidth of the channels at that level is larger than the level below. Every junction in the network is a parallel switch. Messages propagate through the network by moving up in the tree and then back down to the destination node. The processors of the CM-5 are vector processors. Each processing node has a peak speed of 128 megaflops. Each node has 32 megabytes of memory. CM-5s can be expanded from dozens of processors to thousands. 256 processors fit into one cabinet. 2 cabinets are connected to build a 512-node system. 4 cabinets are connected together to build a 1024-node CM-5 with a 5th cabinet added for the highest level of the network tree. The CM-5 is the first supercomputer to bring together support for SIMD-style programming and MIMD hardware in a single integrated programming model. The MIMD hardware allows each node to execute its own program and to send and receive messages over the data network asynchronously. For SIMD-style execution, CM-5 includes global synchronization capability, automatically keeping all the processors in step. Both execution styles are often used in the same program. Most applications can get the first factor of 10 to 10,000 speedup most easily with synchronized operation. Here, for example, an airflow simulation using a mesh with almost 1 million irregular tetrahedra carries out the same operations on all tetrahedra at once. If the mesh used multiple element types, the program would also use the MIMD hardware execution style to maintain optimal efficiency. Other programs, such as molecular simulations, are most conveniently programmed in the MIMD message passing style. The powerful combination of CM-5 data network and control network gives every CM-5 user the best of both SIMD and MIMD. The CM-5 networks do much more than just offer the user the choice of SIMD or MIMD hardware execution. They also integrate I/O devices directly into the system. Devices such as disks and HIPPY channels connect to the scalable data network in the same way that processing nodes do. By using multiple ports in parallel, input-output devices can easily achieve transfer rates of hundreds of megabytes per second. A user in one partition can read and write to a disk device without interfering with processes in other partitions. All these system resources, processors, memory, and input-output devices are available to be applied to a single task at a time. More typically, the processors are operated as 2 or more independent partitions. Messages flowing within a partition may be constrained by hardware to that partition, or tasks within partitions may cooperate and send data to each other via Unix pipes. Each partition may be operated as an independent time-shared environment, executing multiple tasks on a time-sliced basis. Special state-saving hardware allows the network to be drained and restored during context switches. The CM-5 can be programmed in standard programming languages such as Fortran 90. Users develop programs in the X-window-based development environment called Prism. In Prism, users can use the mouse to scroll through the code, view data arrays, switch between numerical and graphical display of the data, and generate histograms showing a performance analysis of all or parts of the program. A grand challenge supercomputer of the 1990s must combine power and flexibility. It must be able to study objects as small as a single atom and as large as a galaxy. By combining powerful parallel nodes with the world's most sophisticated control and data networks, the CM-5 achieves this standard of power and flexibility.